Welcome back. Today we are going to discuss an AP biology question. The link to this question has been given in the description of the video. All the resource links are included in the video description as well. The question is, a researcher is experimenting with nerve transmission using neurons from a giant squid. At the beginning of the experiment, the axon is at rest and has a threshold measured at -70 millivolts at 37 degrees Celsius. The axon receives one stimulus that triggers one action potential in the axon. Subsequent stimuli are much stronger. Which of the following statements explains what happens when several strong stimuli are experienced by the axon? Four answer choices are given here. A. The axon becomes hyperpolarized to -90 millivolts. B. The axon becomes hyperpolarized to -50 millivolts. C. The strength of the action potential becomes greater. D. The frequency of the action potential increases. I will suggest you to pause the video here and try to figure out the problem by yourself. Hope by now you already have figured this out. Let us just now discuss it together. So in order to answer this question, we need to know what is a neuron, what is an axon, what is a stimulus, what is an action potential, what we mean by stronger subsequent stimuli, what is hyperpolarization, what is the strength and frequency of the action potential. I want you to walk you through all the necessary learnings that you need to do before you become confident in order to answer the question correctly. So let us begin. So this is a picture of the neuron from the Wikipedia page. You are familiar with this. This is the cell body with nucleus. These are the dendrites and this is the axon that we are talking about. In the question, what does it do? It conducts electrical impulses away from the neuron cells like telephone wires. These are the axon terminal. They transmit signals to another neuron dendrites or tissues like a radio transmitter. Next. So what are the stimuli or the stimulus? Is a singular. So the main types of stimuli that are known to cause ion channels to open are a change in the voltage across the membrane, mechanical stress, or the binding of a ligand. So all these stimuli, we came to know, they are causing the opening of the channels. What type of channels? Ion channels. Now what can be the stimulus? It can be the voltage. You can see there is a difference in voltage across the membrane. It can be a ligand, either extracellular outside the cell or intracellular inside the cell, or it can be a mechanical stress. In this case, it is called, in case of the mechanical stress, it is called mechanically gated channels. In case of voltage across the membrane, it is called voltage gated channel. And if it is the binding of a ligand, it is called ligand gated channels. Now the mechanical stress can be pressure. And the ligand, it can be extracellular when it is a neurotransmitter. Or intracellular ligands include iron or a nucleotide. So we know about the stimulus and what do they do. Next, we need to know all these terms in order to answer this question. So we know that at the beginning of the experiment, the axon is at resting potential. What does that mean? At rest, a typical neuron has a resting potential, which is the potential across the membrane of -60 to -70 millivolt. That what is they say? We have a resting potential at -70 millivolt in the question. This means that the interior of the cell is negatively charged relative to the outside. During the resting state, that means before an action potential occurs, all of the sodium and potassium channels are closed. These channels are voltage gated because they are open and closed depending on the voltage difference across the cell membrane. So what we came to know, that before the action potential occurs, before we give a stimulus, a cell, the interior of the cell is negatively charged. And at this time, all these ion channels, which are sodium and potassium channels, they are closed. The opening will be triggered by the stimulus, right? And these are voltage gated. We saw three types of stimulus. So this is the voltage gated channel because they depend on the voltage difference across the membrane. So the first kind, depending on the voltage difference across the membrane, these are the voltage gated channels. Now what is depolarization? When the membrane potential becomes less negative or more positive. So initially the interior of the cell was negative, right? Now it becomes less negative. How? The opening of the channels that let positive ions flow into the cell can cause depolarization. So they are no longer in the resting stage. Something has happened. We have given some stimulus and that may have caused the opening of the channels that let the positive ions flow into the cell, and that will make the interior of the cells more positive. Opening of the channels that let sodium ion into the cell is one of the example. So that is depolarization. What is hyperpolarization? When the membrane potential becomes more negative at a particular spot on the neuron's membrane. The opening of channels that let potassium ions flow out of the cell or negative ions flow in can cause hyperpolarization. Like opening of channels that let potassium ions out of the cell or chloride ion into the cell. So we are getting an influx of the negative ions into the cell and the positive ions are going out. So at this stage, the membrane potential is becoming more negative. That is called hyperpolarization. What is repolarization? It means between this depolarization and hyperpolarization, this stage actually occurs, the repolarization. So it brings the cell back to the resting potential. Now what is an action potential? We know that a stimulus triggers an action potential in the axon in the experiment that we are talking about. So it is electrical impulses that send signals around your body, causing a temporary shift from negative to positive in the neuron's membrane potential. It is caused by ions suddenly flowing in and out of the neuron. We have an idea because we knew that there is the influx and outgoing of the sodium and the potassium ions. Action potentials work on an all or none basis. Very important, please read carefully. This means that an action potential is either triggered or it isn't, like flipping a switch. When the intensity of the stimulus is increased, so subsequently if we increase the intensity of the stimulus, the strength of the action potential does not become larger. So how do we show that some information is more important or requires our attention right now? So we have given a stimulus, the action potential has triggered, now we are giving subsequent stronger stimulus. But we came to know that the strength of the action potential does not increase. So how the body will know that, oh, because the stimulus is stronger, this information is more important. So the answer lies in how often the action potentials are sent. That is called the action potential frequency. The stronger the signal or the stimulus, the higher the frequency of the action potentials. So if the stimulus is increased in strength, the strength of the action potential does not increase, rather than it is the frequency of the action potential which increases. And at last we will just look at this graph and I will explain you this graph. This is very important. This is the graph for the action potential. And this actually gives the whole experimentation. So at rest, a typical neuron has a resting potential of here at this stage at minus 70 millivolts. This means we came to know that the interior of the cell is negatively charged relative to the outside. During this resting state, that means before an action potential occurs, we came to know that all of the sodium and potassium channels are closed. Now a stimulus, we are giving this stimulus now, may cause enough depolarization, it's causing depolarization, which lead to the production of an action potential. So action potential is generated due to the depolarization. How? We also came to know that this is because the sodium ions comes into the cell and makes it more positive or less negative. But that is what is called depolarization. An action potential begins when a depolarization increases the membrane voltage so that it crosses a threshold value of around minus 55 volt. So the stimulus is given and when it increases, but as soon as it crosses this threshold of minus 55 volt, we can call it that the depolarization is happening due to the influx of the sodium ions. The interior of the cell is becoming more positive and that is generating an action potential. Okay. So at this threshold, voltage-gated sodium ion channels in the membrane open. So we came to know that. Now the influx of sodium ion makes the membrane potential increase very rapidly. You can see this is a very sharp increase going all the way up to plus 40 millivolts. So this is the peak of the action potential. Now what happens after a short time? Now what happens? The sodium channels self-inactivate. That means they close and become unresponsive to voltage, stopping the influx of sodium. So there is no influx of the sodium ion. A set of voltage-gated potassium channels open and allowing the potassium to rush out of the cell down its electrochemical gradient. So potassium ions are going out. There is much more potassium inside the cell than outside. So when these channels open, more potassium exits than comes in. This means the cells loses positively charged ions and return back towards its resting state. So initially it became more positive or less negative. Now it's again becoming more positive, and ultimately it's coming to the resting state, and that is called the repolarization, we came to know earlier. Now the voltage gated potassium channels stay open a little longer than needed to bring the membrane back to its resting potential. They are still open at this stage. This results in a phenomena called hyperpolarization, in which the membrane potential briefly dips lower or more negative than its resting potential. You can say this is more negative than minus 70 millivolt. Eventually what will happen after this hyperpolarization? The voltage gated potassium channels will close, the membrane potentials will stabilize at the resting potential, it will go back to the resting potential, and the action potential cycle may begin. And it will begin in our experiment, because after giving the first stimulus, we will give subsequent stimuli which are stronger in strength than the first stimulus. Now, the first answer choice, the axon becomes hyperpolarized to minus 90 millivolt. So what we came to know is that when we give a stimulus or subsequent stimuli, the first thing that happens is the depolarization. It is not the hyperpolarization, right? And what happens is it becomes becoming more positive, but what it says, it's becoming more negative. Hyperpolarization means it becomes more negative, but here it does not happen. It is the depolarization which is happening, and it has become more positive. So we can discard the first answer choice. Second, the axon becomes hyperpolarized to minus 50 millivolt. Let's see. So we discarded that it is not hyperpolarizing, it is always the depolarization that happens after the stimulus is given to initiate the action potential. And what about minus 50 volt? So if it is a hyperpolarization, it will be always below or more negative than the resting potential. So in the second statement, both this is wrong. It is not hyperpolarized because it is depolarized, and hyperpolarization means it is always below or more negative than the resting potential. It cannot be minus 50 millivolt. So we discard this answer choice. C. The strength of the action potential becomes greater. Let me read D also. The frequency of the action potential increases. So they are talking about the strength increases and the frequency increases. Now which one is true? If you have remembered here, this is an all or none basis. When the intensity of the stimulus is increased, the strength of the action potential does not become larger. So what happens? It is the stronger the signal, the higher the frequency of the action potentials. This clearly tells us that C is not correct and D is the right answer choice. So let me just select my pen here, if I can, if it allows. So let me choose the green one, and we came to know that D, the frequency of the action potential increases when several strong stimuli are experienced by the axon. That is the correct answer. Thank you all for watching my video. Please like my videos and subscribe to my YouTube channel, Sarkar Research and Education. Here I post videos on test prep math question from PSAT, SAT and ACT. I post AP Chemistry and AP Biology question as well as dashboard analysis. See you all in the next video then. Abhara. Happy learning.